Welcome everyone! Today we're going to build your ultimate geometry toolkit by totally mastering one of the most important topics out there, lines and angles. Okay, let's dive right in. So here's the game plan. We're going to start with the absolute basics, the fundamentals, and then build our way up step by step so you can solve even the trickiest problems and just ace your exams. All right, first up, before we can build anything, we need to get our tools in order. And these are the most essential, the most basic building blocks in all of geometry. First tool in the box, the point. Just think of it as a single, perfect location in space, kind of like a pinprick on a map. It has no size, no width, no length, nothing. It's the simplest idea, but literally everything else is built from it. Next, we've got the line. Now, a line is perfectly straight, and here's the kicker. It goes on forever and ever in both directions. Imagine a laser beam that just never, ever stops. That's a line. But what if you take just a piece of that line, and give it two clear endpoints? Well, then you have a line segment. This is the first one you can actually measure. Think of the edge of your desk or a pencil. It has a clear start and a clear end. And then there's the ray, which is kind of like a mix of the two. It has one starting point, one end point, but then it goes on forever in the other direction. Just think of a ray of sunlight shooting out from the sun. Okay, so let's put it all together. This chart makes it super clear. A line has 0 endpoints and just goes on forever. A line segment is locked in with 2 endpoints. And a ray has one starting point and then takes off in one direction. You have got to know the difference here. This is a classic exam question. All right, we've got our building blocks. So what happens when they start to connect with each other? Well, that's where angles come in. And this is where geometry starts to get really interesting. So what is an angle really? It's just what you get when two rays shoot out from the exact same point. We call that shared point the vertex, and the two rays are called the sides. That space or turn between the sides, that's what we measure in degrees. Now, angles come in all kinds of sizes, and you need to know their names. Let's do a quick tour. An acute angle is a little guy, less than 90 degrees. A right angle is that perfect corner, exactly 90 degrees. An obtuse angle is bigger, more than 90 but less than 180. A straight angle is just a flat line, exactly 180 degrees. And a reflex angle is the big one on the outside, more than 180 degrees. Okay, this is where things get really cool. When we start looking at angles that are neighbors or opposites, we discover all these hidden relationships. And knowing these pairs is the absolute key to solving problems. So what does happen when angles hang out together? Well, this simple question unlocks a whole new set of tools for our geometry toolkit. Let's check out these special pairs. Exam alert, seriously, do that mix these two up. Complementary angles add up to 90 degrees like a corner. Supplementary angles add up to 180 degrees like a straight line. Little tip, C comes before S in the alphabet, just like 90 comes before 180. Okay, 3 more heavy hitters here. Adjacent angles are just neighbors. They share a side and a vertex. Simple enough. But a linear pair is a special kind of neighbor. If they sit together on a straight line, bam, they always add up to 180 degrees. And then my favorite, vertically opposite angles. When two lines cross, the angles directly opposite each other are always equal. These last 2 rules, they're your secret weapons. All right, let's get to the most powerful section in our entire toolkit. What happens when you have 2 parallel lines and a third line, called a transversal, comes and slices right through them? So when that transversal hits the parallel lines, it creates 8 different angles. Now, that looks like a lot, right? But don't worry, because a whole bunch of special relationships pop up, and once you know them, it's like a superpower. Let's break them down. First up, corresponding angles. Just think of them as being in the same corner at each crossing. See angle 1 and angle 5? Top left corner. Angle 4 and angle 8, bottom left. And here's the magic rule. If the lines are parallel, corresponding angles are always equal, period. Next, alternate interior angles. This one has a great visual trick. Look for the letter Z in the diagram. See it? The angles tucked into the corners of that Z, they're also always equal. It can be a regular Z or a backward Z. Doesn't matter, the rule holds. And finally, we have consecutive interior angles. Now hold on, because this one's the exception. These angles are on the same side, squished between the parallel lines, but they are not equal. Instead, they're supplementary. which means they add up to 180 degrees. That's the one you've got to remember is different. Okay, theory's over. We've built this amazing toolkit. Now it's time to get our hands dirty and actually use it on a real exam-style problem. Here we go. Here's our mission. We've got two parallel lines, AB and CD. We're given a couple of angles, and we need to find the values of x and y. Let's put our new tools to work and solve this thing together. Okay, let's walk through it. First, how do we find x? Look, there's that Z shape. That means angle x is an alternate interior angle with a 50-degree angle. So boom, x is 50 degrees. Easy start. Next, let's look at that 127-degree angle. It's on a straight line with the angle inside the triangle, right? That's a linear pair. So 180 minus 127 gives us 53 degrees for that corner. Now we have a triangle, and we know two angles, 50 and 53. And what do we know about triangles? They all add up to 180. So we solve for y, and it comes out to 77 degrees. See, we just chained our rules together. All right, I've done my part. Now it's your turn to practice. Here's a whole bank of questions to make you an absolute master of this stuff. I really want you to pause the explainer here, give these a shot, and build up that confidence for your tests. Let's start with a nice warm-up. These easy questions cover all the basic definitions and rules we just talked about. This is all about building your foundation. Feeling good? Okay, let's wrap it up a notch. These medium questions are more like what you'd actually see on a test. They usually require you to combine one or two ideas to get to the answer. And now for the final challenge, the difficult questions. If you can crack these, then you are truly a lines and angles master. Take your time. Some of these involve proofs and some pretty clever problem solving. So let's do a quick recap. This slide right here, this is your toolkit. We've got the basic blocks, the 5 types of angles, the key angle pairs, and those super powerful parallel line rules. These are the keys that will unlock any problem in this chapter. And hey, remember this, every single expert was once a beginner. Nobody starts out knowing all this stuff. Mastering geometry is just like building a muscle. The more you practice with these tools, the stronger and more confident you're going to get. You have everything you need to solve any problem that comes your way. Keep practicing and keep learning.